All right, so let's do this problem. We have a wire attached to a pole reaching to a stake in the ground. So let's draw it. So I've got the ground. That's a straight line like that. There's my ground. There we go. And there's a pole that reaches up from there. So that's a pole looking straight up in the air like that. Okay. And of course, that's going to be at a right angle. And there's a wire attached from the top of the pole staked into the ground. So like that. All right. And what do we know? We know that a wire is attached to the top of a pole which is staked in the ground 20 feet from the foot of the pole. So this right here is 20 feet. And makes a 58-degree angle with the ground. So 58 degrees. So find the length of the wire. So I want to find this x. All right, well, this looks like a trigonometric problem. So I'm going to write so, ka, toa right here. And I'm going to then come over and put my sides on. What do I know? I know that this makes a arrow pointing to my hypotenuse. Here's my 58-degree angle over here with the ground. So as far away from that as possible is my opposite. And that makes this my adjacent. And what am I looking for? Well, I want to find hypotenuse because that's what I'm trying to find, x. I have my adjacent, but I don't have any information about, nor do I care about my opposite. So when I look, what am I going to be using here? And I have a and h, so I'm going to be using cosine. Right? So what I know is that the cosine of 58 degrees, the cosine of 58 degrees is equal to 0.53, if I just look that up, which, like all cosines, is equal to a over h. So in this case, that's going to be equal to 20 over x. So if I have 0.53 equals 20 over x, if I multiply both sides by x, I will get x out of the denominator on the left. And so I have 0.53 x equals 20. If I divide both sides by 0.53, on this side these cancel and I'm left with x. On this side I end up with 37.74 feet. This one didn't ask me to round, so I'm just going to leave it as 37.74 feet as my final answer.